Hello, my name is Paul Tamse. I'm presenting improved cross-search algorithm to my extreme learning machine based on classification algorithm and application. Now we are going to look at the introduction, what has happened, what has been done. So, CSA is a population-based algorithm. It's a population-based algorithm, so it mimics the behavior of crow birds and their social interaction. They are intelligent birds, which have large brains relative to their body. They live in groups. They hide their food in hiding places, and they can memorize the places where they are bucket hidden their food. Crows can do them by following each other in order to watch their food hiding places and steal their food. If a crow feels like one is following it, it can move to another place far away so that it confuses the one that is following it. So that is what CSA is actually all about. Artificial neural networks is an intelligent computing model for bionics which can perfectly handle both linear and nonlinear problems. Among them, the single hidden layer of feed-forwarding neural networks, which been widely used in many fields because of its good learning ability. Because of the traditional feed-forwarding neural networks, mostly use gradient descent and modify the value of hidden layer used to perform machine learning, perform the machine tested in the iterative process. The model is slow at form. It is extremely sensitive to adjustments in the hypervalues. Here the methods are random. Can randomly generate constant connection weights between the inner layer and the hidden layer. And then the hidden layer neuron threshold before training it. It can overcome some of the shortcomings of traditional feed-forward. This randomized animation is a response speed of the extreme learning machine to an unknown test data. The larger the neural networks in the hidden layer, the more complex the neural structure. An extreme complex network not only has a slow response speed, but also causes increase in computation and improvement in the extreme learning classification method. Okay, so about CSA optimized some swarm optimization. So crows, like I mentioned earlier, crows live in groups and they protect their food with a certain level of awareness probability to prevent theft. Cross-search algorithm has only two parameters, which is the flight length and perception probability. And the cross-search algorithm is easy to implement, and its convergence speed is fast. The cross-search algorithm has certain application research values. It has a strong competitive compared with other intelligent optimization algorithms. This is the model that is used whereby X is in the iterations. The reasonable number, we set a reasonable number of iterations, probably iterate probably 40 times. And then, like I told you, these birds have good memory, so you also set the memory, which is M. Yes, so in the function that is used to generate the for the iteration that have been set is this one here below. It's used, and then CSA has two parameters, has two cases. The first case is the bird doesn't know that it is being followed by another crow that wants to steal its food. That is one scenario. Yes. And the second scenario is that the bird knows that actually there's a crow that is following me that wants to steal my food. So since it knows it is going to move in a number of directions, it's going to move in a number of directions to confuse this one that is trying to follow it. To try to confuse the one that is trying to actually follow it. Yes. Yeah, to confuse the one that is trying to actually follow it. Yes. So this is the model that represents both scenarios. Yes, whereby if the random position that is chosen is greater than the awareness position. So if it is greater than the awareness position, means that the AP is less. That means that the convergence of the model is going to be faster. But if the awareness probability is higher than the position, which is R, random position R, then that means that the model is going to be a global search. It is going to search very many places before it can converge into an actual location where the other bird could have hidden the food. Yes. So okay, this is what I've explained. Okay. So the proposed solution, the proposed PSO solution. Proposed solution is going to try to improve CSA using three aspects. The first one is using the population initialization stage using the tent chaos based on fast learning. For initializing that population. Then the second one is in terms of the flight length, according to the increase in the number of iteration, the size of the flight length is adaptively going to be reducing. Remember, in the first one, the flight length is constant, so it is not changing. But for this improved one, it is going to be gradually reducing. Then the global search or the particle search strategy of the particle swarm optimization algorithm is used to search to expand the search range of the Crow search algorithm. So the PSO model that is proposed in this paper combines the improved Crow algorithm with ELM model. The input weight value and the hidden layer threshold in the ELM are intelligently optimized by the CSO algorithm. The output place on the value is calculated using the Morse generation inverse matrix. Then train the construct and the optimization ELM model into classification of the data sets, and finally use the test to obtain the classification model. Therefore, total time complexity of the improved PSO algorithm to solve the optimal of each generalization is given by this function, whereby Fn is the fitness value, the population size is n, the spatial dimension is n, and O is the time complexity of the algorithm. So this is the flowchart. This one here is the initial one. Where you simply select a bird. Yes, you select a bird, and then you test it against the condition whether the crow knows that it is being followed or it doesn't know that it is being followed. But then this one, the improved one, here we have the population that is where they're using the tent chaos method to initialize the population, which is more efficient. Yes, then in summary, the improved strategy for the PSO elimination algorithm does not increase the time complexity of the algorithm solution compared to the initial CSA algorithm. Okay. Now this is about the data set that is actually being used to verify the performance of the data set. They're using 8 different data sets, 4 of which are going to be for regression, and the other remaining 5 used for classification. Yes, in order to verify the PSO algorithm has better performance in terms of convergence and optimal speeds, the proposed PSO is compared with the CM algorithm, the differential exponential ELM algorithm, and the function test. Yes, and this is how the actual test is actually performed. And this is a sample of the data that is generated from the experiments that are being formed. So in conclusion, we try to analyze the performance of the related defects ELM and use the improved CS algorithm to solve them by introducing the behavior of the following current optimal solutions in the particle sum optimization algorithm. The shortcomings of the initial one are slow and very fast to fall into the local optimal solution. The improved model is used to optimize the hidden layer neurons and concept and connections weights of the extreme learning. Yes, on the extreme learning machine neural networks. So as to obtain the accurate prediction results, the proposed model has been verified on classification, regression datasets, and speech recognition, and the results show accuracy of the improved algorithm has been correspondingly improved. Now, the limitation of of the model that has been proposed, the algorithm proposed, and this paper loses a certain amount of group diversity because the group tends to move in the direction of a local optimal solution every time the algorithm is updated, and each of the algorithm is not improved accordingly. Thank you very much. These are the references, and thank you.